I did a bunch of review before we started, but this is where we kind of landed, and I want to review this, okay? So when you have a transversal that intersects lines that are parallel, then we know that all of these things are going to be true, okay? And so here you're looking like you're going to be given the fact that lines are parallel, okay? And so you should observe that all of these angle pairs that we have a name for are true. Okay? On the other hand, if they're asking you, hey, can you tell me whether or not these two lines are parallel? Then you're going to have to show one of these, right? You just have to show me that one of the following is true. You pick, right? Sometimes one is easier to prove than the other, so you're just going to have to go by that. Underneath these two boxes, I'll tell you that you can use, okay, these are always true. These properties are always true, no matter what. Okay, it doesn't matter if lines are parallel or not. Okay? Make sure we follow now, okay? Ecom and Amber, make sure we follow now, okay? So always true. So you can use the sum of triangles is equal to 180, okay? Sum of a four-sided shape, the angles inside would be 360. That a straight angle is always equal to 180, okay? By that I mean one of these, right? You can always use that. You can use the fact that vertically opposite angles are always equal to each other, and by that I mean, right, when two angles they have the same sides, right, that created, those are vertically opposite. These are always going to be true, as well as supplementary angles. Supplementary angles where you've got two angles here, they add up to 180, and complementary angles, you've got a 90 happening, right? And so you've got complementary is 90, supplementary is 180. So those on your study sheet I would have, like these you can always use to find other angles that are missing, guys. These are your tools in your toolkit. Let me zoom into that because I know it's a little small. And you can make sure you get that right. These are always true. You don't need lines to be parallel to be able to use this, okay? Make sure you write this down. I would have these on my study sheet, and I will call these like tools to find missing angles no matter what. Okay. Vertically opposite angles are congruent, and this is the kind of like a little picture to remind you of what they are. I would also have a little box in on my study sheet that tells me what do CIAs look like, what do corresponding, what do they all look like. Okay. Let me zoom out a little bit. These are the ones that I am referring to. Make sure you have these on your study sheet on page 5. I will at the top of this thing write down add to study sheet. That's a must, okay? On page 5, add these 4. And it can be very, very small, okay? Like I'll show you, because sometimes it's overwhelming, right? Like what am I supposed to do here to help me out? So I will show you. On page 6, I'm going to go back to 6. And maybe all you have to do is right next to these entries here, alternate exterior, I'm going to erase this here. I don't know if you did the same already, but maybe this is a good help. Alternate exterior, it would look like this, right? And then I will just use my highlighter. I'll be like, it's this one and this one. Okay, that's an alternate exterior. Alternate interior looks like this. Okay. Okay. Alternate interior are there. Maybe you don't like highlighters, you just do one of these. Okay. One of these. There. Corresponding. I'll go off on that one. Corresponding look like this. It's that one right there and this one right there. Okay. And then consecutive interior, I'm running out of space here. But consecutive interior would be this one and this one. They're both on the inside. Okay? And then you have a little diagram that helps you immediately figure out which one am I talking about. Mm-hmm.
What CIA?
CIAs?
Yeah.
These are CIAs. Consecutive interior angles. That's what CIA. So these four are the exact same here. They're exactly the same, except where we're doing different things. If lines are parallel, then all these properties are true. If you're trying to figure out lines are parallel, you have to show that one of these, at least one of them, is true. So there's different approaches to these. Okay, let's go to 7 and let's put this to the test. I give you a few steps up here, proving if lines are parallel. Try to find an angle pair with a name. I call them one of the four: AI, AE, corresponding, or CIAs. Like, try to find one of the four. Can you see them on your diagram? You might have to resort to the toolkit, right? Sum of triangles, supplementary angle, vertically opposite, all of those that I just gave you, you might have to use those to find more, okay? Check to see if the property about them is true. If yes, lines are parallel. So we go AB is parallel to CD. If no, we go AB is not. You cross out that parallel symbol, CD, and don't always use AB and CD, but that's kind of like the notation we want to be using here. Okay, so let's try. We tried one already on Wednesday. Okay, we looked at this diagram and we noticed these two here, and we have a name for them. They're corresponding, and the property about them is true, that they're the same, they're congruent. That's why we could say that EF is parallel to GH. Or we could have used these two that we also have a name for, alternate exterior, and we also realized that the property about them is true, that they are equal, and so therefore EF is parallel to GH. Now, listen to this part, okay? Because students are, oh, they're always going to be the same. What if this had been 113 and this had been 112? Are they still alternate exterior? They're still alternate exterior. Yeah, I'm going to mess with you a little bit, right? They're still alternate exterior, but what do we know about them? They're not the same, right? In that case, we would have to say, well, EF is not parallel to GH. So the name is not going to change. The fact that these are alternate exterior is true. What you want to look for is them being equal to each other. Okay? So that's something you want to look for. Let's keep going here. So I'm asking you, is EF parallel to GH? And immediately, maybe try to, do we have a name for these two angles? Alternate. Well, there's a problem. Is this one interior? If it had been here, you're in business, but it's not, right? We don't have a name for these ones. So note, don't have a name for angles given. So what are we going to do? Use toolkit. What happened there? Use toolkit. Okay, the ones that are always true. Let's use those. And try to be efficient here. If this is 70, guys, what's this one here? 70, right? Why is that? What property did I use there? Vertically opposite angles. Yes, yes. So I figured out these two. Why? I'm just going to say vertically opposite angles, okay, are congruent. That's how I got that one. That was my first step. Now, do I have a name for these two angles? You can check your notes. Yes. Consecutive interior angles. Yeah, they're CIAs. Okay. So now I'm going to highlight that as like, okay, I have a name for them. And I will say consecutive interior angles. Are they equal to 180? Are these two equal to 180? No, it's 179, right? So I'm going to say the property that I know about them is not true. It is actually 179 if you want to write down on the side what the sum is. Therefore, in this particular case, we would have to say that EF is not parallel to GH. That's it. Okay. Let's do a little bit of investigating here. If this is 109, what is this one here? We have a straight angle here, right? If this is 109, then this is 71, correct? Do we have a name for 70 and 71? Do we have a name for these two angles here, that pair? Is it corresponding? Would you agree? What do we see about corresponding? Are they equal to each other? Because we want them to be equal to each other, right? They're not, correct? So that would also be another way to show that lines are not parallel. So it doesn't matter how you slice it. It does not matter how you slice it. You will end up with the same answer. Okay? In fact, once you have one angle at this intersection here, you can find all of them. Watch it. If this is 109 and this is 109. If this is 71 and this is 71, right? Over here, if this is 70, then this is 110. This is 110, then this is 110. So you can actually, if that helps you fill out the whole thing, no matter where you look at all the corresponding angles, they're never equal to each other. Okay? They're never equal to each other, so it's not, these lines are not parallel. Think of it this way, another way of thinking of parallel lines. They're exact copies of each other. This line right there, if you're saying that this line is parallel to that one, they're exact copies of each other. So we should observe the same angles all around, but we're not. Okay, so that's another way of putting it. Let's keep going. Let's make this a little bit more complicated. Again, the question is still, is EF parallel to GH? Still the question. Let me just close this door here. It's going to get very loud. Okay. Let's see what we can do. Now, I know it's Friday, you're tired, you're just thinking of the weekend right now. This is not first thing, right, in your mind right now. One thing that I want you to remember is there's only one transversal that you can be on at any given time. Okay? You can't have more than one transversal. So if you, for example, say, okay, I'm going to consider this transversal here, right? What can I find along that transversal? If you choose to travel along this transversal, you can do that. And you figure out what is along that transversal, what is there, what are the corresponding angles here. Listen carefully. When you travel on this transversal, there are corresponding angles here. Alternate interior, alternate exterior, all four are present along this transversal. Guys, got it? If you jump to this transversal, if you travel on this one, then there's all four of them, the ones we have a name for, are along this transversal. But please don't mix them up, okay? You have to be in one transversal at a time. So, what about this one? If I travel along this line right here, I have the 75, right? Do I have any angles around here that can help me out? No, I'm stuck. I can't make any. The 40 belongs to this top here, okay? There's not another line that cuts through like that. So I can't do anything here. Let's go over to this one, the 65. Is the 65 gonna be, can I compare it to any angle over here? The answer is no, it's empty. So what else can I do? Somebody help me. Let's look at our toolkit. What can I do to give me some more angles here? Ian?
Sum of triangle.
Sum of triangle. That's right. You see a bunch of triangles there, I'm sure? There's one right here. Doesn't really help me a whole lot. But I have this triangle right here. I don't know if you see it. So I'm going to highlight that one. There's a triangle right there. So note, I will say this again, note, no name. Yeah, hold on. Hey. Page 8. So you've got the triangle there. We have no name for given angles. You don't have a name. So use toolkit. The ones that are always true. I'm going to use sum of triangle. Yeah, so let's do this, okay? For our purposes, I'm going to give it an angle here. I'm going to give this a name. I'm going to call this angle X. So angle X is going to be 180 minus 40 minus 75. And that gives me 65. And what I want you to get used to, if at all possible, just give me an explanation, because that's where we're headed. I'm going to give you like a table, and you're going to come up with the number of the value of the angle I'm asking you for, and some sort of explanation as to how are you explaining your answer. Okay. So now I know that this is now I know this is 65 here. And do we have a name for these two? They're along that one transversal, right? They're alternate interior. Alternate interior angles, in this case, are equal to each other. They're both 65 degrees. If you want to be more specific, they're both 65. Therefore, I can now say that EF is parallel to GH. So the fact that these two lines are parallel is now undisputed. It's a fact that this line is parallel to that one. So even though we don't know the answer, what do you think if this is 75? What can we now say about this angle there? It will also be 75. If this is 75, what are these two angles called again? corresponding, right? This is also 75. So you could actually, now that you've determined this, you can actually now use the properties that we know and just fill in everything else, okay? All right, let's go to 4. Right now, I'm not too worried about exactly how you show your work. I just write something down, add things to your diagram. I don't care about that. I just want you to start thinking about it. So I want you to show me here is EF parallel to GH. Remember, you can only pick one transversal at a time. Try to prove it or disprove it. Is EF parallel to GH? Try that. I'm going to focus in. There's this transversal right here. There's this transversal right here. And to make, just so you know, I could technically travel along this transversal or this transversal. But right now the question is this one parallel to that one? So I want to find one of the lines that cuts through it like this. And I recognize that we have a name for these two, right? Along this transversal. So let's call this T1 and this is T2. Along transversal 1, we have a name for given angles. Okay? When that is the case, it's actually much easier. You don't need to go to your toolkit and find more angles. You just look at them. Okay? And these are CIAs, right? Consecutive interior angles. Can I say that they're equal to 180? Let's see, right? If you add these up, it gives you 180 exactly. They are equal to 180. Check. Therefore, EF is parallel to GH. That's it. So sometimes it's as easy as that. And I don't know if you tried this one. You might have tried this. Oh, this is alternate something. Actually, this is nothing. Because one is inside, one is outside. So if they had both been outside, you could have called them alternate exterior. If they had both been inside, alternate interior. We have a name for those. We have corresponding, but it doesn't apply. We have CIA, which wouldn't help you a whole lot. But if you had wanted to, here you would have had to go into your toolkit. Vertically opposite, this is 103, right? 103 and 77, that's also 180. So if you had wanted to work with the second transversal, you just had to do a little bit more work. Okay? Note, same answer, same conclusion with T2. This is just a note. I don't want you to do it in multiple ways. Just do one, right? So this is proving. This is the one that students like the least. You're going to not like this one as much, but I'm going to make you like it, hopefully by the end of this unit. Okay? Now let's go on to the second part, which is just fill in missing angles. This one students enjoy a little bit more. So let's go to page 9. I'm going to start nice and easy, and then I'm going to ask you to do some yourselves. Okay. One thing you notice when you look at this diagram, I am telling you, the diagram is telling you that lines are parallel. That's not even a question anymore. Okay? And I will make a note at the top of this. Note, lines are parallel. Okay? You know that at the top corner here. That means that alternate interior, right? Alternate exterior and corresponding angles will all be equal to each other. like the pairs, and CIAs will add up to 180 degrees. This is something that is just a fact. Those are the 4 things that you're guaranteed when lines are parallel. Okay, so for this one, I want you to, we're going to just stick with the question mark for now. I know some teachers would probably like frown on this one. Just use question mark, okay? So I want you to do this for every single one. Question mark is equal to, what would this be equal to? 116, right? You can actually write that down here. So it's equal to 116 degrees, and I want you to do this. Why? Because alternate exterior angles are always going to be congruent if lines are parallel. That's your explanation. That's your justification. So take this time to really familiarize yourself with the explanation. Next, question mark here. And again, the fact that they're parallel is not disputed. That's already a fact. This would be 100, right? But the problem is why? Why would you make that statement? Because these are alternate interior angles, and we know that they're going to be the same. That's just a fact. Okay. So I want you to do those for the next couple, like all the ones that remain on this page. But come with me. I want to show you when you have more lines in the mix. You know what? No, I'm going to ask you, I change my mind all the time. I'm going to ask you to work from questions 1 all the way to 10 for now. Okay? I'm just going to take it easy. Try questions 1 to 10. Doing what I just did, okay? All right, let's keep going. Just a quick check here. This is 57, so I hope that you all know that it's 57 degrees. Why? Alternate exterior angles are congruent. Okay. There was a question here. What's up with sometimes just one arrow on each line and sometimes 2? It doesn't matter. As long as they have the same amount of arrowheads, you're fine. Okay. What this is saying is this one is parallel to that one. So let's say you had 1,000 lines, but only these 2 lines had 2 arrowheads, and you would know that those 2 indeed are parallel to each other. Okay. Keep going. This is 130. Why? Because alternate interior angles are congruent. We just know that because lines are parallel. I'm going to do 6. I'm going to skip some of them. But question 6, this one is 79. So we'll actually show some work here. I tend to go 180 minus 101, and that's 79 degrees. Why? Because this is the reasoning. Consecutive interior angles are supplementary, right? They're equal to 180 degrees. So that's where it changes a little bit. That's the one where you cannot say they're not equal to each other. They're supposed to add up to 180. Okay? Keep going. I think the rest, I'm just gonna, there's not a single corresponding angle. So I apologize for that, but I didn't make this worksheet. There wasn't a single corresponding angle scenario, which is too bad, but you're gonna come across that, okay? Let's change it up a little bit. It's still kind of asking the same as we've been asking here, but look at this, look at what it says here. Find the measure of the indicated angle that makes lines U and V parallel. You want these lines to be parallel. What would this have to be? Well, angle question mark would have to be 180 minus 63, right? That gets me to 117. If this is 117, then both of these would add up to 180, which is exactly what you want. Okay. Let's keep going. Things don't really change, even though there's a lot more lines going on here. What do we call these two here? They are consecutive interior still, so question mark is 180 minus 134, and that is 46 degrees. Why? Because consecutive interior angles equal to 180 degrees. So remember, just travel along the one transversal at a time. What do we call these two here? What are they? Corresponding, right? And so question mark would have to be 89 as well, because corresponding angles would have to be equal to each other. And keep going. What are these two angles called here? What do we call those? Corresponding, right? These are corresponding, even though there's a bunch of lines. Okay, so question mark would be 73 degrees because corresponding angles are congruent, they're equal to each other, and so forth. So I want you to keep going through those. Let me skip ahead a little bit. Okay. Nineteen. That's what I'm asking you to solve. Determine the value of x. Okay. I'm going to do one or two, and then I'm going to ask you again to take some time to answer all of those questions I've just had there. Lines are parallel, okay? That's not a question. What do we know about these two angles here? They are going to be, they're alternate exterior, and we know that alternate exterior angles are equal to each other. So you're going to go 21x plus 6, that angle, you can do it in brackets if you want, is going to be exactly equal to, what's that box? What does that represent? 90. Okay? So here we go. We can get rid of the brackets. 21x is plus 6 is equal to 90. I'm going to continue up here because it's going to get too messy if I'm going to copy this again. We want to isolate for x at this point. I don't know if your teachers ever talk about bringing terms over, but I will. So when you bring terms over, what happens to the sign of that term? It changes signs, yes, minus 6. So you end up with 21x is equal to 84. Then you divide both sides by 21. And so x will be equal to 4. It's actually degrees. Okay, so you solve for x there. Now I'm going to skip a few to show you the on page 14, question 25. What do we call these two? CIAs, right? And we know that these two are supposed to add up to 180 degrees. So that means that x plus 96, that is some weird expression of the first angle, plus x plus 96, right? We're adding up these two angles, and they're supposed to be equal to 180 degrees. So this is the one instance where you add these angles, and then you make them equal to 180. Okay, you cannot say that this one is equal to that. You will add up your angles and then make them equal to 180.
So another question. If we know that the angle is supposed to be 180, right? Can't we just do 180 divided by 2?
No, because they're not, it might be that in this case they are actually equal to each other, but they won't always be half. They won't be half-half, okay? So that's yeah, make sure you don't do that. So here we go. We don't have anything multiplying the brackets. Nothing is in front except for a 1, so we can get rid of the brackets. Then we combine like terms. I don't know if you're familiar with that term. X and x gives you 2x. 96 plus 96 will be 192 is equal to 180. So some algebra comes in here. I bring this term over to the other side. So it's 2x is equal to 180 minus 192. 2x is equal to negative 12. And then we divide both sides by 2. X is equal to negative 6. And that's degrees. What? Negative 6 degrees? What's up with that? Yes, that's okay. Let's check. If you plug in negative 6 in here, negative 6 plus 96 gives you 90. Negative 6 plus 96 gives you 90. So it happens to be the case that they're both 90, okay? That's just coincidence. Okay. All right. These two here, they're side by side. You got to handle them the same way. All of the other cases, angles are equal to each other. So what do I mean by that? I'll set up 27 for you so you know what I'm talking about. These are all corresponding. So in this case, you can just go 6x is equal to 5x plus 10. You know what I mean? Like, so alternate exterior, interior, and corresponding, you make them equal to each other. CIAs, however, you got to be a bit more careful. You got to add the two angles and then make them equal to 180 degrees and then solve for x at that point. Okay? So I'm going to ask you to work through pages. Practice what we've just done. Pages 10 all the way to 14. I will give you the answers to some of these. Sorry, you can't see that, right? Sorry. Try pages 10 to 14. Write down the answers because I want you to know right away where you're at. Okay? So on this page, for example, on page 14, I'll put the numbers in brackets, okay? So for 26 here, you're supposed to get 7 degrees. Hold on. I got this one wrong. This one is 4 degrees. For 28, it's going to be negative 9 degrees. And for 27, it's going to be 10 degrees. So write down those numbers so you know. Let's go to 13. On page 13, I'm going to give you the answers to those as well. So question 20 on page 13, you're supposed to get 7 degrees. Question 22, you're supposed to get negative 7 degrees. Question 24, you're supposed to get 5 degrees. This is all on page 13 right now. For question 23, you're supposed to get 9 degrees. For 21, you're supposed to get 8 degrees. And so I'm just going to give you those answers. The other ones, I'm going to just let you work through them. So start on page 10. I already did most of 10. 10 is probably done for you already, so start at 11 all the way to 14. And I will post the answer key, and we'll see how that goes.